right, so moving forward, we're talking about geometric sequences. By the end of this lesson, you'll be able to determine whether a sequence is geometric versus arithmetic. You'll be able to find sums, just like before, as well as write general formulas for geometric sequences, just like how you did for arithmetic. Okay? So, geometric, the difference between that and arithmetic is that you're multiplying the previous term by what's known as a common ratio, and that variable is an R. Big difference from arithmetic. Arithmetic is called a common difference, hence the D, and for geometric, it's common ratio, hence the R. Okay? And you can find what the common ratio is by taking the second term and dividing it by the first term. Okay? Or taking the third term and dividing it by the second term. Or the fourth term, dividing it by the third term. That's also how you show something is geometric. A sequence is geometric. Okay? So, like arithmetic, you were adding a common difference every time, and you were subtracting to determine or to show that something's arithmetic. Geometric is the opposite. You're multiplying the previous term by a number. To show it's geometric, you're dividing. Okay? Exact opposite. And you have your general formula, u sub n equals u sub 1 times r, all raised to the n minus 1. Sorry, let me fix that. Only r is raised to the n minus 1. You multiply your first term by whatever that is. Okay? U sub 1 is still the same. It represents what? Your first term. N represents term number, number of terms. U sub n. Huh?
U sub n.
No.
The number of that term number.
So that nth term, whatever number that is. And then r is your common ratio, the number that you're multiplying the previous term by. So consider the sequence that I need to write down, because I forgot to add it in. So we're going to consider the sequence that I'm about to write in. We're going to show that it is geometric. We're going to find a general formula for that sequence, and then we are going to find the 12th term of said sequence. All right, so here's the sequence we have. It's 8, 4, 2, 1, 1/2, and so on and so forth. We need to show that the sequence is geometric. Okay? So like we explained before, remember when you have to show that something is either geometric or arithmetic, you actually need to go through the mathematical process of showing that the common ratio is the same amongst all your terms. So you take your second term, you divide it by your first term. What is that?
2. 1/2.
It's 1/2. Your small numbers on top is always your second divided by your first. Your third divided by your second. Is that 1/2?
Yes.
Yes, it is. Your fourth divided by your third. Well, that's exactly 1/2. And then your fifth divided by your fourth. What is that? You have a fraction within a fraction. That's still 1/2, okay? The common ratio is the same between all of your terms. So there you go. That is part A. That is how you show that something is geometric. Now we have to find the u sub n general term. So we use the formula. And we plug in what we know. What's our first term?
8.
8. Our common ratio is 1/2. You can either put that in parentheses or you can put that with the binary x. Do not use the multiplications out, okay? That's not used in the IB world, okay? And use the binary x. That dot means something completely different. And then raised to the n minus 1. Do not multiply u sub 1 and r together to get 4. That is incorrect, okay? You're only raising your common ratio to the n minus 1 power and multiplying that by 8. So once you get here, that's it. You're done. Okay? So no combining like terms, no extra stuff like how you have to do for arithmetic. That's it. You're done. says hence. Hence means use what you just found to solve the 12th term. Where are you gonna plug in 12?
You sub in 12 in.
For n. Nice and simple. We definitely gotta go towards our calculator for this. Unless you guys know what 1/2 to the 11th power is.
Yeah, we or so far. Really got me there.
Okay? Now I got a question. If you noticed, this particular sequence is getting smaller, right? We're multiplying by 1/2 every time. What's 1/2 times 1/2?
1/4.
1/4. What's 1/4 times 1/2? 1/8. What's 1/8 times 1/2? 16. And so on and so forth. So when you do this in your calculator, yes, you're going to get a decimal, but better believe that that decimal can convert back to a fraction. So make sure that when you raise that to the 11th power and you click enter, how do I convert that back to a decimal?
Oh, I got it. That's awesome.
What is it? I thought I heard on this side. You go to math, fraction, enter.
Wait.
Yes.
Doesn't get 11
Because then you'll be just raising 2 to the 11th power, not 1
So
power.
it's U1 times R2 over 256.
So your answer is going to be 1/256. Okay? Questions? Always try to convert it back to a fraction, guys, especially with geometry. Here's the next one. Here's another example. So how do you know if a sequence is geometric? How do you know?
By finding the ratio.
By finding the ratio. How do you find the ratio?
Divide
Second by the first, third by the second, fourth by the third, so on and so forth. And no matter what, that ratio should be what?
The same.
The same. It should be equal. Same thing you do when you're trying to figure out if something's arithmetic. You subtract the second from the first, third from the second. No matter what, that number should be the same. So when you're trying to figure out if, like in this case, the value of k, and you have consecutive terms of a geometric sequence, you're going to take your second term divided by your first term to get your common ratio. You'll take your third term divided by your second term to get your common ratio. And no matter what, these two ratios should be equal. Yes?
If it tells you that they're consecutive terms, you have to do both of them still.
Because basically what you're going to end up doing is you're basically creating an equation that's going to allow you to solve for k. So when you have the ones for your arithmetic, you should have done something similar, except instead of division, you would have had subtraction, but you still would have set them equal to each other. And so what you have here is proportion. You guys remember how to solve proportions? Cross multiply. Okay? So I'm going to multiply cross. I'm going to multiply 2k times 2k. What is that?
4k squared.
4k squared. And then that's going to equal what I get when I multiply k minus 1 by 21 minus k. How do I multiply that out?
Oil. Oh, wow. Oh, loving it.
Okay. So what's k times 21?
21K.
First, outer, what's k minus k times a negative k? Negative k squared. Your inner, what's negative 1 times 21? And your outer, what's negative 1 times negative k? All right. If you notice, you can combine some like terms, correct? And I'm just going to go ahead and put it in descending order. Because what you should notice is this is not like the other problems with arithmetic. Because before or you just had a regular k, didn't you? This one we have a k squared, which means that this is what type of equation? Quadratic. Okay? Quadratic.
Chat at.
All right. So, you guys, to solve a quadratic, okay? You guys remember how to do that from your algebra 2 days?
Can you just plug it in the calculator?
You can plug it in your calculator. I hear something about some negative b. What was that called? Quadratic formula. You can also factor.
Oh,
Okay?
good. No.
But for the sake of this, and I mean we're gonna spend some time on quadratics anyway. Okay, I'm gonna show you guys how to do this using your calculator. First thing that we need to do is we need to get everything on one side. Okay, we can either be the left side or the right side, it really doesn't matter. Okay, so we have 0. I'm gonna subtract over a 4k squared, making this a negative 5k squared plus 22k minus 21. You need to get everything equal to 0. And then we're going to go to our calculator, and we're going to type this equation in to y equals. Okay? Does everybody have this written down? So go ahead and type this equation into y equals. Okay? I mean, you can, but I also want to show you guys this other way. Remember, instead of using k, we're going to use x. Okay?
You can use K though, right?
Because it's not going to serve as a variable. It's going to just serve as a letter, and it won't register
So is X like the only thing that will serve as variable?
in this mode that we're in. Yes.
So
If you change the mode to like polar or parametric, it does change the variable, but you don't have to worry about changing that. Is everybody good to go?
I don't know anymore.
Type your equation in, and we're going to graph this, okay? Now, I know for me, I had to adjust my window in last time I used this, okay? So I'm going to go back to my standard window by pressing Zoom 6. Zoom 6 will always take you back to a standard negative 10 to 10 window. So that way I can at least kind of know where I'm starting from. Oh, there we go. So I can see my whole quadratic. Okay?
So you just sketch that. If it was on a test and they gave you a graph, you would just.
And you would just sketch that. You kind of see that this maximum point is a little like 2, 3, and then you know it crosses in between 1 and 2, and right at 3. Go zoom, just regular zoom, and go 6. K is basically the places where your graph crosses the x-axis, okay? Now, I don't remember if you guys did this last year, but this is how you go about finding the x-intercepts of any type of equation. You'll go to second, and you'll go to trace. Please make sure that you guys stay with me, okay? I just pressed second, and then I went to trace. Trace is right beside the graph button. You should see these options right here. What happened?
What is this? What is this?
So again, by going to second trace, this allows us to basically find the places on where the graph crossed the x-axis, which are our values for k. Now, second trace also pops up some other options, like if you wanted to find the maximum point of that quadratic, which we'll do later, we'll do that in the future, you're going to go back to this option. If you wanted to find where two lines intersected, instead of going through the old school system of equations, elimination, substitution, you can use this. Okay, but for the sake of this particular example, we're going to go to option 2, which is 0. 0 also means x-intercept roots solutions. So we click enter. Now, does everybody see left bound at the bottom of their screen?
Yeah.
That means we have to go to the left of the x-intercept that we're trying to find. Okay, so we're going to start with this one first. Now, my cursor right now is located at 0, negative 21. So I have to press this right arrow over so that way I can see my cursor. I'm pressing the right arrow over so I can see my cursor. It was not even on the screen before. Now, I'm going to it just to the left of the x-intercept. Here's the x-intercept. I need it to the left, which would be some part along this graph. Does everybody understand that? That's what left bound stands for. And you click enter. Is everybody still with me? Now it says right bound. You have to go to the right of this x-intercept. So I'm going to continue to go over, move my cursor. My cursor is now to the right of this x-intercept. And click enter one more time. Now, if you have a fancy calculator like mine, you're going to have these nice little lines, which basically show that my x-intercept lies in between them. If you don't, you still have these two like triangles up here at the top. These two triangles should, if you were to draw your own lines, you should see that it's, the x-intercept falls in between them. And before clicking any more over arrows, you click enter, where it says yes. And basically what the calculator is going to do is it's going to find the x-intercept for you, which is 1.4. So the value of k is 1.4. One of the values of k is 1.4. Okay? It's only long because you haven't done it enough to be quickened. Okay? So we have 1.4. That's one value. We have to find the other value. Now I know very well, just like how you can see, what's the answer? What's the answer to the other x-intercept? It's 3. Okay? But let's get the practice on using this feature. So where do I go? Second trace. Where do I go from here? Go to 0. Go down to option 2. Now it says left bound. I need to go to the left of this x-intercept. Is that going to be above it or below it? Above. So I'm going to move the cursor over so that it's closer to that x-intercept, not the other one, because I don't want the calculator to get confused. But it's still to the left of that x-intercept. Yes. Like if I started left bound where I was originally, it wouldn't, like it has to take out of the fact that, you know, there's still a maximum within that area. So you want to try to get close to whatever it is that you're looking for. Now I have to go to the right. Go to the right of that x-intercept. Click enter again. Again, these two triangles should be in between your x-intercept. And it is. So there we go. Here's another type of example. So the geometric sequence has use of 2 as -6 and use of 5 as 162. We're going to find its general term, use of n. So, just like with arithmetic, you have these types, okay? You know, there is the way of pushing the terms down and going through that process, just like how we did before. There is a shortcut, okay, just like how there was one for arithmetic. In my opinion, I think it's shorter. Sorry. In my opinion, I think it's shorter. There's one also for geometry. Would you like to see both ways? Or you would just see the short way? Okay. So, it's similar to the process for the other one, okay? But we're not going to subtract anything because we're dealing with geometric here. We're going to divide, okay? So, we're going to take our terms, and this does matter, okay? Like, order now does matter, okay? Since my fifth term is further down the sequence, you always start with the term that's further down the sequence, okay? So we're going to take that term, which is 162, and we're going to divide it by the term that's earlier in the sequence. So in this case, it's -6. Everybody still with me? Okay. And what we're going to do is okay. You are going to subtract where your terms are located. So 5 minus 2 is what? 3. going to be the exponent of your ratio. And you set them equal to each other. So if you have to write it out in words, you know, is your ratio raised to the difference between where they're placed in the sequence, and then you just divide the two terms. So we have r to the third equals, what's 162 divided by 6? Negative 6. And then we just have to solve for r. This is how we find our common ratio. How do you solve for r? How do you get rid of that cubed? Not square root. Cube root. Because it's the third power, so you take the cube root. The cube root and the cube cancel each other out, so you're just left with r. And what number times itself 3 times gives you a negative 27? Negative 3. So there's your common ratio. You can do this in your calculator. If you go to math, option 4. So math option 4, type in a negative 27. Oops. Wrong thing. You'll get your ratio. If you had to take the 4th root or the 5th root, type the number in first, go to math, go down to option 5. That allows you to do 5th roots and 4th roots and 6th roots and 7th roots. Sometimes when you do the subtraction, it won't always be 3. It might be 2, but it might be bigger. And then you just type the number in, and you'll get it. So now that we have our common ratio, let's find our first term, because we need that, okay? We need to use one of our terms. We use our second term or our 5th term. Second term? Cool. Doesn't really matter. You can use your 5th term. Just look at the same answer. So, you'll have u sub 2 equals u1. We know our ratio is negative 3, and we're going to plug in 2 for n. Now, we already know that u sub 2 is negative 6, so we plug that in as well. And what's 2 minus 1? Just 1. Anything raised to the first power is just itself, so that really is just negative 3. How do I solve for my first term? A little louder. Divide by negative 3. And what's negative 6 divided by negative 3? 2. So there is my information to write my equation. Alright, last little bit is I'm gonna skip over this example. I'm gonna get to series. Did y'all run out of time? These are your formulas for geometric series. Very straightforward. Okay? Use your formula, plug in, Charlie, hold up. Geometric series, just like arithmetic, you're adding each term. This time is geometric. U sub 1 times r raised to the n minus 1 all over r minus 1. Please make sure you know, and your calculator knows that you're doing r minus 1, that entire denominator. Because you will, end up getting weird numbers. So be careful on how you type it in. Alright, so here we go. We're trying to find the sum of 2 plus 6 plus 18 plus 54 plus etc. to the 12 terms. So, what's n? 12. What's my first term? 2. What's my common ratio? 3. 12 again is n minus 1 all over 3 minus 1. Now, does it matter what formula you use? No, it really doesn't, because they literally are the same thing. It's just your 1 and your r are switched. Okay? Be careful on how you type this in. If you can save yourself some time, do so. What's 3 minus 1? 2. Okay? And hey, would you look at that? 2 and 2. Those cancel out. Will they always cancel out? No, they won't. But make it a little bit easier on yourself, okay? I would hate for you guys to do all the work right, but then when it goes to type in, you don't get the right answer because you don't know how to type it in. So really, 3, 12 minus 1, sorry, 3 to 12 minus 1 is going to be our sum of all these numbers that go up to the 12th term. So type that in. And I want one person to read me off the series of numbers that represents the sum. Huh? 4, 4. That's it. Is it 531,440? Good stuff. And yes, you could have achieved that before even doing any kind of simplifying. Just make sure that if you wanted to plug all your work in to the calculator at this point, you include parentheses around the denominator. And please make sure you include parentheses around that r to the n minus 1 part. Okay? Question on that? Alright, so backing up, we're looking at this last example before we go back to series. It says find the first term of the sequence that exceeds 1400. So we have the first 4 terms of the sequence, and we're trying to figure out, okay, which term exceeds 1400. So we're going to end up using our general formula here. And the thing is that we're trying to find is n, because we're trying to figure out which term exceeds 1400. We know our first term is 6. And if you look here, our common ratio, what do you think it is? If you notice, from 6,
Also, we were interested in the.
Sorry about that. If you notice, you go from 6 to 6 square root of 2 to 12 to 12 square root of 2. The common ratio is a square root of 2. Okay? If you multiply 6 by the square root of 2, you end up getting 6 square root of 2. If you multiply that by the square root of 2, well, that's nothing but 6 square root of 4. Square root of 4 is 2. 6 times 2 is 12. And it continues on like that. So that's your common ratio. You don't know what n is, but you are looking for that value when it exceeds 1400. So for this, I am going to use my calculator to help me out here. And actually, if you want to be correct, actually mathematically correct to the problem, it's asking when it will exceed 1400, which means you're looking for when it's going to be greater than 1400. So what I'm going to do is I'm going to go to my calculator. I'm going to type this into y1, and then I'm going to look at the table to see exactly which term is going to exceed 1400. So I'm going to go to my calculator. I'm going to go to y equals, clear this out, and I'm going to type in 6 times the square root of 2. And then I'm going to raise it to the x minus 1. Okay, remember, I can't plug it in. I have to use x because that's the only variable that the calculator will take. And then I'm going to go to second graph. And there you go. 6 square root of 2 is 8.4853. There's 12, so on and so forth. So I'm going to go down. I'm going to try to figure out where do I exceed 1400. Click the button too many times. As I can see, in my 16th term, I'm right inside of the thousands, but it's my 17th term when I exceed 1400. So my answer for this is n is going to equal 17. And that's my answer. That's the first term where it's going to exceed 1400. Back to series. We're trying to find a formula for S of n for the first n terms. Okay? Remember, here's the formula, just to recap. I'm using the other one. first term is 9, and my ratio is actually a negative 1/3. Okay? It's a negative 1/3. Because if you notice, the terms are oscillating between positive and negative, positive and negative. The only way that happens is if you have a negative common ratio. And then that's going to be raised to the nth power, all over 1 minus a negative 1/3. And actually, I wrote the formula down wrong. And that's it. That's all it's asking for. I don't need to distribute the negative through because then that's actually changing the orientation of my common ratio. My common ratio is negative. That's the only way I'm going to isolate in between the positive and negative numbers. So I need to be sure that you don't distribute that negative over. Okay? At least not at the top. At the bottom, you certainly could. And then 1 plus 1/3 is 4/3. Okay? And then that will be acceptable from there. If you want to keep change flip, you can do that too. Last example says the geometric sequence has the first term of 5 and a common ratio of 2. The sum of the first n terms of the sequence is 635. Find n. Doing something very similar. This time we're just using the sum formula. Our first term is 5. Common ratio is 2. We're going to raise that to the n power. And then we're going to do 2 minus 1. Well, 2 minus 1 is nothing but 1. So I'm going to simplify this a little bit more before I go into my calculator to figure this out. Okay? Now I can figure this out 2 ways. All right? I can plug this in for y1, this in for y2, graph the 2 and see where the 2 curves intersect each other. Or I could just plug in this equation into y1 and then look at the table. Either way, I still will get my answer. So I'm going to show you using the table way just so we can get the answer there. Okay? It was 5 times 2 to the n minus 1. Look at my table. I'm looking for where it exceeds 635, okay? The table takes me back to where I last left off, so I have to go up. And bam, there it is. N is 7. Now, if I wanted to do the other way, if you do it by graphing, I go to y equals, I type in one equation for y1, the other equation in for y2, and I graph. There is the equation for the sequence, but I'm not going to get to see my other line because my other line is a horizontal line that crosses the y-axis at 635, which means that I have to change my window. Window is the second button over. I have to change my y-max so that way I can see 635. So I'm going to do 640, just so it gives me a little bit of space when I graph, so that way I can see that line. So there's my curve again. And if you notice, this looks like a solid line because there's so many in between. And bam, there's the other one. And right there, that point of intersection is going to tell me what value actually equals 635. To find that out, I go to second, trace, go down to option 5, which is intersect. If you notice my cursor is down here, I'm going to move my cursor closer to the intersection point. It doesn't have to be right on the intersection point, it just has to be closer. Okay, that's good enough. And I'm going to click enter 3 times. 1, 2, 3, and there it is. Okay? So either way, using the table or the graph, you can find a point of intersection, which basically tells you the value in.